So, hi everyone. In the previous class, we have discussed about velocity, potential, and stream functions and all of the details, and we have also completed one small problem. But I would continue to give a brief idea once again so that the brushing about these portions would give you more idea or will make in your mind much more clear. So, speaking once again, velocity function, it is defined by the symbol phi, phi, and it's nothing but 0 with a slash symbol, a Greek letter, and it's defined as a scalar function of space and time such that its negative derivative with respect to any direction would give the velocity, the fluid velocity in that direction, or in mathematical terms, dou phi by dou x. Negative of dou phi by dou x would give you the velocity u, minus of dou phi by dou y would give you the velocity v, and minus of dou phi by dou z would give you the velocity w, where u, v, and w are the velocity in x, y, and z axis respectively. So negative direction of phi in any direction x, y, and z, that is minus dou phi by dou x, minus dou phi by dou y, and minus dou phi by dou z. So this is what is known as a velocity potential function, and this in cylindrical coordinates we can represent it by or cylindrical polar coordinates we can represent it by ur, where ur is the velocity component in the radial direction, and u theta it's the velocity component tangential direction. Ur is nothing but it's defined by dou phi by dou r, and u theta is nothing but 1 by r of dou phi by dou theta. Okay, where okay, so how will you this already we have discussed what is velocity potential function phi should satisfy the Laplace equation for a flow to happen. So in order, if any flow is given, that should be defined or that should be satisfying the Laplace equation, which is nothing but dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square is equal to 0, which is an important significance and which plays an important role in the fluid mechanics or kinematics of fluid flow to define the velocity potential function. Next, what are the properties of the potential function? We have described about the rotational components, which is nothing but wz, wy, and wx, where wz means half of dou v by dou x minus dou u by dou y, and wy is half of dou u by dou z minus dou w by dou x, and wx is equal to half of dou w by dou y minus dou v by dou x. This w, what I am representing as the rotational component, is written in capital letters, and this w, what I have shown over here, is the velocity component in the z-axis. So how I have mentioned these values, I have already explained in the previous session. You have rotational components as x, y, and z. So see, for example, you have the rotational component like x, y, and z. You go in this direction x, and then in the direction of y, and then in the direction of z. This is how you will go in the clockwise direction, x, y, and z. So first component you have x over here, in the next component you have y over here, and we have to represent the z-axis. If you need to represent the rotational component in the z-axis, it would be the rotational component in the xy plane. So how will you write z, x comma y, x comma y, and whatever is opposite velocity in that term, that you will get it as the velocity in that component, and similarly the velocity in the x component you will get it as u in that component. So this is how you will write the wz, wy, and wx, where wy is the next component would be z and x. You will represent it as dou u by dou z minus dou w by dou x, and wx would be nothing but x, y, and z. This is how you will write half of dou. And what is the opposite velocity in the x, y axis? It would be dou w, and the opposite velocity in the z axis, just considering y and z, it would be dou v. That is how you will write it. And I hope you have all made it clear in this session. So if the values are substituted based on this, and if you solve for this, you will get the relation that wz is equal to 0. That means the rotational component is equal to 0 if you substitute the Laplace equation in this equation, in the previous equation. What you will get is known as the satisfaction of Laplace equation. Similarly, we have the w, sorry, similarly we have the wx and the wy and wx. the wz, wx and wy is equal to 0, which means all the rotational components are 0. That means if all the rotational velocity components are 0, the flow is said to be irrotational. That is important. How you can know whether the flow is rotational or irrotational? We have already discussed what is meant by an irrotational flow, what is meant by a rotational flow. These are all important terms. How we can describe rotational means if there is a each fluid particle is rotating about its own axis and then it's also flowing in the same direction like this. Or if irrotational means it is not rotating about its own axis, it would be just flowing along the pathway. That is known as irrotational. Okay. So what are the properties? If the velocity potential function exists, then the flow is irrotational. If the velocity potential function satisfies the Laplace equation, it's said to be a steady, incompressible, irrotational flow. Those are the important properties for the velocity potential function. If the velocity potential function exists, the flow is irrotational. If the velocity potential function satisfies the Laplace equation, it's a steady, incompressible flow. We have also gone with a problem for this where the velocity potential function was given in terms of minus x y cubed by 3 minus x square y plus x cubed y by 3 plus y square. And how we have solved for that? The velocity components in the x and y direction, and show that the phi represents a possible case of flow. That means we have to solve it for the Laplace equation. We have already discussed what is meant by Laplace equation and all. So based on this, we have to solve it. So first thing first, write the given equation minus x y cubed by 3 minus x square plus x cubed y by 3 plus y square. And other kind, sorry for speaking just in English. Since your medium of instruction should be in English, that is why I'm continuing in English itself. Okay. So velocity components, you can write the velocity components. How will you write the velocity component u? That is the velocity in the x-axis will be minus of dou phi by dou x. We already described that. That is minus dou by dou x of minus x y cube by 3 minus x square plus x cube y by 3 plus y square. So after that, how will you write the velocity? The differentiating with respect to x. That means the differential of x would be 1 with respect to x. So y cube by 3 plus differential of x square, that is 2x, plus differential of x cube, that is 3x square, into y by 3, and differential of y square with respect to x would be 0. And taking the negative inside, you'll get over here positive, again the negative positive over here, again the negative inside, you'll get negative over here, and this term cancels out. So you'll get y cube by 3 plus 2x minus x square. So this is the velocity in the x-axis. So similarly, you can find the velocity in the y-axis. V is equal to minus dou phi by dou y. That is equal to minus of dou y, and you represent it as minus x y cube by 3 minus x square plus x cube y by 3 plus y square. Okay. So how will you get the velocity? So how you get the velocity is 3xy square by 3 plus 0 minus x cube by 3 minus 2y. That means the velocity you can represent it by x y square minus x cube, that is 3 and 3 cancels, x y square minus x cube by 3 minus 2y. So you got the velocity in the x-axis, you got the velocity in the y-axis. So after that, how you can, that means the first portion of the problem is over. You got the velocity in x-axis, you got the velocity in y-axis. For phi to be possible in case of fluid flow, it should obey the Laplace equation. That is how you will solve and check whether the flow is possible or not. That means നമ്മുടെ ഫ്ലോ പോസിബിൾ ആണോ അല്ലയോ എന്ന് അറിയാൻ വേണ്ടി ലാപ്ലാസ് ഇക്വേഷൻ സാറ്റിസ്ഫൈ ആണ്. ദാറ്റ് മീൻസ് ഡോ സ്ക്വയർ ഫൈവ് ബൈ ഡോ എക്സ് സ്ക്വയർ പ്ലസ് ഡോ സ്ക്വയർ ഫൈവ് ബൈ ഡോ വൈ സ്ക്വയർ പ്ലസ് ഡോ സ്ക്വയർ ഫൈവ് ബൈ ഡോ ഇസഡ് സ്ക്വയർ should be equal to 0. Since you have the components only in the x and the y axis and not much in the z axis, that final term of dou square phi by dou y or z square would be not present, or it would be neglected. So just dou square phi by dou x square plus dou square phi by dou y square. So how we solve it? First you write dou phi by dou x is equal to dou by dou x of, write the term of phi, minus x y cube by 3 minus x square plus x cube y by 3 plus y square. This is the value of your phi value. We are differentiating it with respect to x. So how will you differentiate x with respect to x? It is 1. x with respect to x, the differential of x would be 1. So minus y cube by 3 minus x square, that would be differential of that differential would be minus 2x, and the differential of x cube would be 3x square y by 3 plus, and the differential of this term would be 0. So you will get minus y cube by 3 minus 2x plus 3 and 3 cancels, x square y by x square y. So we have to first find dou square phi by dou y square. So dou square phi by dou y square would be, we will again differentiate this term, that is dou by dou x of minus y cube by 3 minus 2x plus x square y. Okay, so differential of that term would be, we are differentiating, the differential of this term would be equal to 0 because there is no x term. The differential of this term would be x raised to 1, differential of that would be just 2, so differential of that would be minus 2, and x square would be 2xy. So substituting that, minus 2 plus 2xy. So this is the value for dou square phi by dou x square. After that, we have to equate it for dou square phi by dou y square. So first differentiate with respect to y one time, then again differentiate it with respect to y the second time. So how will we solve it? First, dou by dou y square of minus xy cube minus x square plus x cube y by 3 plus y square. Okay, substitute that and you will get it as dou by dou y of minus xy cube. The differential with y cube would be minus 3xy square. Okay, minus 3xy square, 3 and 3 cancels, plus the differential of this term, it is 0. We are not having a y term, so this would cancel us. We are differentiating it with respect to y, so this, there is no y term, it cancel. The next term, x cube y by 3, we have a differential for y which is 1, so 3x square by 3, that is 3x square by 3, and finally the differential of y would be y square would be 2y. Okay, next there is no 3x square, sorry, it's just x square, cancel this term, there is no x square, remove this, I'm just erasing it from here. Okay, sorry. Okay, there is no this is just differential of this term would be x cube by 3. It would be actually x cube, it's a small mistake over here, it would be x, sorry, it's a small x cube over here. X cube by 3. Okay, I hope it is clear to everyone. The differential of this would be x cube by 3. Okay, because we are differentiating it with y. Okay, so d squared phi by dy square, what you will get, we are going to differentiate this again with respect to y. So xy square, the differential of that would be 2y, and we have a negative, so minus 2y into x plus the differential of this term would be 0 because there are no y components over here, plus 2y, the differential of this term, it would be 2, so minus 2xy plus 2. And what was the previous term? The previous term, the d square phi by dy x square and 30 minus 2 plus 2xy, that means this and this cancels. We add these two, this and this cancels, it is adding 2 and 3 in the first equation. For substituting 2 and 3 in the first equation, we have minus dou square phi by dou y square plus dou square phi by dou y square would be equal to minus 2 plus 2xy plus minus 2xy plus 2. So substituting that, all these terms cancels, that means you will get the Laplace equation to be 0, which clearly shows that it's a possible case of fluid flow. I hope that was already clear to everyone. So to this portion, every portion where our previous class will discuss every portion was discussed in proper manner. Okay, and after that, now we will go to now we will go to the velocity stream function. Sorry, we have also discussed about this velocity stream function. It is nothing but a scalar function of space and time such that its partial derivative with respect to any direction gives a velocity at right angles to that direction. That means we are representing it with the symbol psi, psi. That means u with a line over in the center. Dou psi by dou x would be the difference, that term would give the velocity in the opposite direction. That means velocity at 90 degrees. That means dou c by dou x would be v and dou psi by dou y would be minus u. Just equate it, you'll get the velocity stream function. So in polar coordinates, how you represent u r and u theta? That means in opposite terms, you'll write it in opposite term. One u r would be 1 by r dou psi by dou theta. Just the opposite of what you have studied in the previous velocity potential function. So u theta would be minus dou psi by dou y. And this is for polar coordinates. Polar coordinates is nothing but you are representing it r and theta. Next, 2D stream steady incompressible continuity equation is given by dou by dou x plus dou v by dou y. Substitute that of u and v in terms of the stream function psi, dou psi by dou y and dou psi by dou x instead of u and v. We substitute that and you'll get it is equal to 0, which is an important term. If psi is satisfied, that means the stream function is satisfied, the continuity equation for a particle in case of flow, the flow can be irrotational or rotational. That is an important term what we have discussed in the previous class. What is the flow is rotational or irrotational. That means if the equation for psi is satisfied, then it can be a possible case of rotational or irrotational. If you are writing in terms of the velocity rotational components, that means wz, that means rotation in x and y axis, 1 by 2 dou v by dou x minus dou u by dou y. And substituting u and v values are substituting for u and v, we have wz is equal to 1 by 2 dou by dou x of dou psi by dou x minus dou by dou y of minus dou psi by dou y. So substituting that, if the flow is rotational, we will get the W irrotational. That is what we are always getting. The WZ, WX and WY is equal to 0. Then we call it for an irrotational flow. Substituting that, you will get dou square psi by dou x square plus dou square psi by dou y square is equal to 0, which is a Laplace equation in terms of psi. So that is what we have discussed in the previous class also. So based on this, the properties of velocity stream function psi. If a stream function psi exists, it's a possible case of fluid flow, which is rotational or irrotational. That means if you are getting the value of psi, psi may be expressed in terms of an equation, linear equation, and if the psi exists, no, it's a Laplace equation satisfy that. If psi exists, it may be a possible case of flow, in which it may be either rotational or irrotational. That is an important thing. This may be an either case of flow in which the flow may be rotational or irrotational. So if the stream's function phi satisfies the Laplace equation, it is a possible case of irrotational flow. That is an important thing here. The stream function psi satisfies, it's a possible case of fluid flow, which is rotational or irrotational. If the stream function satisfies the Laplace equation, it is a possible case of irrotational flow. So we have already discussed about a stream function example also in the previous, but we are brushing it again for you to understand. A stream function, the stream function value psi is equal to 5x minus 6y. We are asked to find the velocity component and also the magnitude. How will you find the velocity component u and v? The magnitude would be square root of u square plus v square, and the direction of the resultant velocity at any point. So psi is represented by 5x minus 6y. So u would be minus dou psi by dou y, which is equal to minus dou by dou y of the differential of this term 5x minus 6y. The first term, the differential would be 0 because there are no y terms, and the second term minus 6y would be, the differential of that would be minus 6, and you have a negative over here which would be coming to 6 units per second. And v is equal to dou psi by dou x, so dou by dou x of 5x minus 6y. And if you are differentiating it again with respect to this term, the differential of this would be 5, and the differential of this term would be 0. That means 5 units. So you got the u as 6 and you got the v as 5. Remember this term. So v would be ui plus vj, 6i plus 5j. So the total, this is capital V, remember, and each small u v in the velocity in the x-axis and the velocity in the y-axis. So substituting that, you will get v is equal to square root of u square plus v square, or square root of 6 square plus 5 square. So substituting that, 6, the square of that would be 36 plus 5, the square of that would be 25. The square root of that means 6 plus 5, 11, 66, square root of that would be 7.81 units per second. That is the magnitude. ഇതായിരിക്കും നിങ്ങളുടെ magnitude of the total velocity for this fluid flow. And what is the direction of that? Tan theta would be v by u. That means you ask the magnitude and also the direction. Direction would be v by u. That is 5 by 6. So substituting that, theta is equal to tan inverse 5 by 6, which is 39.81 degree. We have discussed till this portion in the previous class, and I was brushing through this portion. Okay, so next we will go through a problem which is much more important. So let's continue. So if a two-dimensional potential flow, the velocity potential is given by phi is equal to x. We have also discussed this. 2y minus 1. Determine the velocity at the point 4 phi. Determine also the value of stream function psi at that point. That means you are given the value of potential function. Our potential function phi value തന്നിട്ടുണ്ട് 2x into 2y minus 1. നമുക്കൊരു പോയിന്റ് തന്നിട്ടുണ്ട്. പോയിന്റ് നമ്മുടെ ഫ്ലോയ്ക്കകത്തുള്ള ജസ്റ്റ് നമ്മുടെ പോളാർ കോർഡിനേറ്റ്സിൽ സിലിണ്ടറിക്കൽ കോർഡിനേറ്റ്സിൽ എവിടെയെങ്കിലും റെപ്രസെന്റ് ചെയ്യുന്ന 4 ഉം 5 എന്നും പറയുന്ന 2 പോയിന്റ്സും തന്നിട്ടുണ്ട്. So you are asked to find the value of the stream function at that point. You are asked to find the value of stream function at that point. So how will you do that? So first write the equation of the phi. Phi is equal to x into 2y minus 1. Substituting that inside, 2xy minus x. So how will you find the velocity in x and y direction? In x direction, it would be minus dou phi by dou x. Then the differential v would be minus of dou phi by dou y. So minus of dou by dou x of 2xy minus x. The differential of the first term, the x would be x raised to 1. It would be cancelling out. So it would be minus 2y plus 1. How? Because you're taking the minus inside. Minus out of minus 2y plus 1. Similarly, the velocity, it would be minus dou phi by dou y. That is minus of dou by dou y of 2x y minus x. We are differentiating this term with respect to y. Then e cancel minus x and 0. Final term minus 2x. That is your final term. Okay. So ഇതിന്റെ രണ്ടിന്റെയും 4 ഉം 5 എന്ന് പറയുന്ന കോർഡിനേറ്റ്സിൽ വാല്യൂ കണ്ടുപിടിക്കാനാണ് പറയുന്നത്. സോ u, the magnitude of the velocity u at 4,5 would be 2y plus 1 at 4,5. That is minus 2 into the value of y would be 5. 5 plus 1, which is minus 10 plus 1. That is minus 9 units per second. And value of v would be minus 2x plus 1. That is minus 2 into 4. So substituting that, it would be minus 8. Okay, minus 8 units per second, and value of v would be ui plus vj. So that is minus 9i. Okay, plus minus 9i minus 7j. So you got the magnitude of velocity would be square root of u square plus v square, minus 9 square plus minus 7 square. Okay, sorry, this is 8 over here. I made a mistake over here. This would be 8 over here. Okay, 8j minus 8j over here, and this would be minus 9i. Okay, and substituting that, u square plus v square minus 9 square plus minus 8 square. Substituting that, 81 square plus 64 square. That means something around you have 144. That is square root of that would be 12.041 second. So till this portion we have described, and we were brushing through the portion. We will continue. So we are going to continue again for the next portion. So determine the stream function. We have to first, we have found the values of u and v in the function. Now we have to determine the stream function. You can solve it in either ways. So നമുക്ക് phi യുടെ value തന്നിട്ടുണ്ട് 2xy minus x. Okay, 2xy minus x, your value is given. You have to find the velocity here, the phi in terms of psi. Okay, the velocity u would be minus 2y1, and velocity v would be, that means velocity in x would be minus 2y plus 1, and velocity in y would be minus 2x from a and b. So how you will represent in terms of the stream function psi? u എന്ന് പറയുന്നത് minus dou psi by dou y, and that means minus dou psi by dou y would be, write that value, minus 2y plus 1, and rearrange it. That means you take the negative to the other side. Dou psi by dou y would be 2y minus, it's minus over here, 2y minus 1 over here. Okay, 2y minus 1 over here. And how will you get dou y, you take the sorry, dou psi. I will look at dou psi look at dou y, the right hand side lot on the 2y minus 1. It is 2y minus 1 over here, 2y minus 1. Okay, it is 2y minus 1. Okay, 2y minus 1 over here. Okay, into dy. And how will you find psi? Differential of this term. That means differentiate 2y minus 1 dy. That means 2y square minus y plus c. That means the value of psi would be y square minus y plus c. But remember, this is the value of the stream function. ഇതാണ് നമ്മുടെ stream function value. But also you need to find the value of constant. The constant is unknown. How will you find the value of the constant? So differentiating, we write the dou psi by dou x. The dou psi by dou x, that means the velocity in the v. It would be dou, we are just differentiating it. V square minus y plus c is equal to dou c by dou x. Okay, because this term and this terms we are differentiating it with respect to x. We have no x term over here, but x we don't know the value. It's just a constant term. So what will you do? It's y becomes 0 because this is a variable, but c is a constant. So when you are differentiating it with respect to a constant, it is dou c by dou x. So you know that dou psi by dou x is equal to v. That means minus 2x. We already know what is the value of b, minus 2x. So dou c by dou x would be equal to minus 2x. And c, how will you find the value of dou c? Is equal to, you take the dou x to the other side, minus 2x dx. So c would be minus into x would be x squared by 2. So you'll get it as minus x squared. Substituting the value of c in the equation, psi would be y squared minus y minus x squared. So you got the value of c and you got the values of the function. Substituting the value for the stream function also. This easily proves the value of stream function. Now you can equate it for the value of psi, which is 4, 5. So value of y is already known, 5 square minus 5 minus x is 4. So minus 4 square. So 25 minus 5, 20 minus 16. That you will get it as 4 units, which is the value of stream function. So to this portion we have discussed. We will go for another problem also. The stream function for two-dimensional flow is given by psi is equal to 2xy. Calculate the velocity at the point p is p 2, 3. Find the velocity potential function phi also. Okay, so this problem. So in this, the stream function for a two-dimensional flow is given by psi is equal to 2xy, and you are asked to find the velocity at the point 2, 3. Psi is equal to 2xy. So how you solve it? You first find the velocity in the x and y axis. U is equal to minus dou psi by dou y, which is nothing. Which are first നമ്മൾ ചെയ്യുന്നത് u b കണ്ടുപിടിക്കാനാണ് നോക്കുന്നത്. u എന്ന് പറയുന്നത് minus of dou psi by dou y. That means minus of dou y into psi, which is equal to 2xy. So differentiating that with respect to y, so which would be minus 2x. And similarly b എന്ന് പറഞ്ഞാൽ എന്താ dou psi by dou x in terms of the stream function. We are just remembering, we are representing in terms of the stream function. Dou psi by dou x is equal to dou by dou x of 2xy. Substitute that with respect to x. So what, with respect to x, it would be 1. So 2 into 1, that is 2y. So you got the velocity. Remember this, you have the psi value is 2xy. You need to find the velocity at the point 2, 3, and also find the velocity potential function. Now the problem just opposite. Okay, so psi is equal to 2xy. Substitute the values of u and v. You get it as minus 2x and plus 2y. U is equal to minus 2x and plus 2y. So now substituting the value, magnitude of total magnitude, V is equal to, capital V is equal to Ui plus Vj. That means minus 2xi plus 2yj. And at the point 2, 3, that അതിനകത്താണ് നമുക്ക് കണ്ടുപിടിക്കേണ്ടത് 2, 3 x ന്റെയും y ന്റെയും value substitute ചെയ്യുക. That's a simple term. Minus 2 into 2, which is x over here, I plus 2 into 3. The 3 value is y over here, j. So substituting that, minus 2 into 2, minus 4i, plus 3 into 2, 6j. So that means the magnitude would be minus 4 square plus 6 square the square root of that term, that means 16 plus 36, square root of that, it's equal to 52. That means 7.21 units per second. This is important term. Already important, and you should mention the units per second. That is important. Okay, you got the magnitude of the velocity. So the question psi, the stream function തന്നിട്ടുണ്ട്, psi is equal to 2xy. ഇതിനകത്ത് നമ്മൾ phi കണ്ടുപിടിക്കണം, phi യുടെ value, the velocity potential function. So psi is given as 2xy. So from this we have to find the potential function. You know u is equal to minus 2x and b is equal to 2y. Substitute that. U is equal to, you all know from the potential function. Potential function നമുക്ക് ആദ്യമേ അറിയാം. എന്താണ് u എന്ന് പറയുന്നത് the negative derivative, the velocity in that direction. So u is equal to minus dou psi by dou x. So minus dou psi by dou x എന്ന് പറയുന്നത് എന്താണ്? Already you have know the value of u, minus 2x. So equating that, negative negative cancels out. So dou psi by dou x is 2x, and you take the dou x to the other side. So dou psi is equal to 2x dx. Differentiate or integrate that. Dou psi is equal to integral of 2x dx. So how will you find psi? Psi is equal to 2 into x square by 2, 2 into x square by 2. Integral of x എന്താണ്? 2 constant ആണ്, അത് പുറത്തെടുത്ത്. Integral of x എന്താണ്? X square by 2 with respect to x plus a constant, because there is a constant always whenever you are having an integral or limits അല്ലെങ്കിൽ എപ്പോഴും ഒരു constant term കാണും. So phi, the velocity potential function is equal to x square plus a. So നമുക്കൊരു constant ഇതിനകത്ത് കിട്ടി. ഈ ഒരു constant ബേസിസിൽ നമുക്ക് നേരത്തെ ചെയ്ത പോലെ തന്നെ phi വീണ്ടും equate ചെയ്ത് we have to solve it. So how will we solve it again? So dou phi by dou y is equal to dou by dou y into x square plus c. You already know the value of the previous function. So that means we are differentiating. Either നമ്മൾ ഇനി y വെച്ചാണ് differentiating. This variable with respect to y would be always a 0. But ഈ ഒരു constant term ആകുമ്പോൾ നമുക്ക് അറിഞ്ഞുകൂടാ എന്താണ് value എന്ന് അറിഞ്ഞുകൂടാ. അതുകൊണ്ട് maybe it can be something related to x, or it can be something which is related to y. എന്ത് വേണമല്ലോ. So that is why dou phi by dou y would be is equal to x, differential of that would, or differential of x square with respect to y would be 0. So what is remaining? Dou psi by dou y. So but a potential function എങ്ങനെ represent ചെയ്യാൻ പറ്റും? The potential function we can represent it by dou psi by dou y is equal to minus v, and dou psi, and how will you represent it? Minus 2y. We already know the value of v. V എന്ന് പറയുന്നത് എന്താണ്? Minus v എന്ന് പറയുന്ന value 2y ആണ്. So substituting this again into this, that means dou minus 2y is equal to dou c by dou y. Rearranging the terms, dou c by dou y is equal to minus 2y. So dou c equal to, taking dy to the other side, minus 2y dy. Substituting that and getting the equation. So you will solve it for the integral of dc. Dc is equal to integral of minus 2y dy, and substituting that, c is equal to minus 2 y square by 2. That means you got the value of c. The constant value എത്രയാണ് കിട്ടിയത്? c എന്ന് പറയുന്നത് minus y square. Okay, after getting that നമ്മൾ first equationൽ solve ചെയ്യുന്നുണ്ട്. Substituting for y is equal to x square minus y square. Okay, this is എന്നുവെച്ചാൽ നമ്മൾ തൊട്ട് മുമ്പ് കിട്ടിയായിരുന്നു എന്താണ് c എന്നുള്ളത്, minus y square. So x square minus y square, and this is your stream function equation which carries the most of the important, the final answer of this. ഇതാണ് വളരെയധികം important. The final answer of that would carry maximum marks. Okay, the x square minus y square. Now substituting for phi is equal to 2, 3. So substituting for phi is equal to 2, 3. So x square, you know the value at x is equal to 2, and for y it is equal to 3. So start substituting that. X square you will get it as 4, and for 3 square you will get it as 9. So substituting that, you will get the value as 5 units. Okay, so I hope till this portion you were having doubts, so you were not having any doubts. So we have already discussed this portion in the previous session. That means the velocity, potential function, stream function, etc. I was just going through the detailed understanding. So before continuing to the next portion, let me mention you again that this is very much important about the types of motion. Types of motion വളരെ important ആയിട്ടുള്ള portion ആണ്. Okay, what is meant by types of motion? Okay, so that we will discuss in the next session of the class. Okay, thank you.